In this video, we will prove that root 2 is an irrational number. Similarly, you can prove that root 3 is an irrational number and root 5 also an irrational number. Now, if you know proof of any of them, then you can prove the others. The same way you can prove the others. Now, we will prove the method of contradiction. So, what is method of contradiction? Here, root 2 is an irrational number we need to prove. Now, we assume that the opposite, that means let root 2 is a rational number and has no common divisor. So what does common divisor mean? Common divisor means if you think 4 divided by 6, so 4 divided by 6 is not the simplified form, because you can simplify that more and you can write 2 divided by 3, right? So we need to consider simplified form. That means there is no common divisor. So suppose we can write root 2 equals to m divided by n, because if it's a rational number, then we can express that m divided by n, where m and n are integers. So integers means the whole number, and it can be positive or negative, and n cannot be 0 because we cannot divide anything by 0. So if you square both sides, you will get 2 equals to m square over n square. So n square can be written as m square over 2. Since n is an integer, so n square is also integer. That means left side is an integer. Since this is an equal sign, so right side would be also an integer. Now since m is an integer, m square also integer, so we can divide m square by 2. So this means 2 is a factor of m square. Now if 2 is a factor of m square, then 2 would be also factor of m. You can think, suppose m square is 16. So you can divide 16 by 2. That means 2 is a factor of 16. Then if you take square root of 16, then that would be 4. So 2 is also factor of 4. That means you can divide 4 divided by 2. Okay. Now since you can divide m by 2, so you can assume m divided by 2 is an integer. So we can write m equals to 2k for an integer k. Now if you plug m equals to 2k in equation 1, then it would be n square, and it would be 4k square divided by 2. Now if you cancel, it would be 2k square equals to n square, and k square can be written as n square over 2. Since k is an integer, so k square is also integer, so left side is an integer. Similarly, right side is an integer, so 2 is also would be a factor of n square and for n. Same case like this one. So from here we see that 2 is a factor of m, and here 2 is also a factor of n. That means 2 is a factor of both m and n. This is a contradiction. Why? Because at the beginning we assume that we don't have any common divisor. There is no common divisor. At the beginning we assumed, but here we found that m and n has divisor 2, has a factor 2. So this is a contradiction. So root 2 would not be a rational number. That means root 2 is a irrational number. Similarly, you can prove root 3 and root 5. You just need to change the digit. So here we have root 2. Now square root of 3. So square root of 3 can be written as m over n. So if you square both sides, then you can write n square equals to m square over 3. So 3 is a factor of m square, and also for m, like this one. So m can be written as 3k for an integer k. Now if you plug m equals to 3k here, then it would be n square equals to 9k square over 3, and k square can be written as n square over 3. So from here you can see that 3 is a factor of n square, also for n. So 3 is factor for both m and n. This is a contradiction because at the beginning we assume that there is no common divisor. So square root of 3 cannot be a rational number. That means square root of 3 is an irrational number. And same way you can prove this one. So now you can prove any number like square root of 7 is an irrational number, square root of 11 is an irrational number, square root of 13. So I think now you can prove any of them. So thanks for watching.